Hi, this is George Diamond again. This is our next video in the flipped classroom unit. Now, the last several videos we've been looking at evaluating limits analytically. And we're going to continue with a special type of problem that has a particular technique that we're going to have to use to evaluate our limit. So we always try direct substitution first. Now, if direct substitution will work, I mean, if all you have to do is just substitute 0 in for x and you're done, you want to try that first. So let's go and try direct substitution. Let's see if that will work here. So we end up with the square root of 0 plus 1 minus 1 in our numerator over 0. Now 0 plus 1 is 1. We end up with 1 minus 1 over 0, which is 0 over 0. Now remember, anytime we have 0 over 0, that indicates a hole in our graph. Holes we can remove. So let's take a look at removing the hole from this type of function. Right, now to remove our hole, now if you notice this function, you've got a radical in your numerator. So the radical is part of a binomial. So you got the square root of x plus 1 minus 1. So it's part of a binomial. So the technique that we're going to use is called the rationalizing technique. So basically it involves rationalizing the numerator. That is getting rid of the radical out of the numerator. Now a lot of students are used to rationalizing the denominator, removing the radical from the denominator of a fraction. Right? But now in this case, we're going to remove the radical from the numerator, and then from there we should be able to cancel something out. So let's see what happens. Now to rationalize the numerator here, we have to use the conjugate of the binomial. Now you got the square root of x plus 1 minus 1. So we'll put parentheses around this to make it look like a binomial. So what we're going to do to rationalize it, so we're going to multiply this binomial by its conjugate. Now the conjugate will be the square root of x plus 1 plus 1. So we're going to multiply that to the numerator. Then we're going to multiply the square root of x plus 1 to the denominator. Because remember, whatever you multiply to the numerator, you got to multiply to the denominator also. Now, whenever you multiply two conjugates together, you will always end up with a difference of two squares. So multiplying these in the numerator will give us the square root of x plus 1 squared minus 1 squared. All that divided by x times the square root of x plus 1 in our denominator. Now, when you square the x plus 1, that removes the radical. This gives us a 1 squared, and we end up with x plus 1 minus 1 in our numerator. All that divided by x times x plus 1 in our denominator. So see what happens? So when you multiply the two conjugates, you end up with a difference of two squares. So the two terms of squares. So the square root of x plus 1 squared minus 1 squared. Now when you square the radical, basically that removes the radical. And then here you've got 1 squared. So what happens in the numerator, 1 minus 1 will cancel out. So those will cancel out. And we end up with x in the numerator. So the x that's left in the numerator is going to cancel out with the x on the outside of our parentheses here. So you see the x over x, that's the whole. That's the problem. So before we can do this, we had to remove the x's. So this x will reduce to 1 with this x down here. So those are going to cancel out. And that gives us 1 over, let's come down here, 1 over the square root of x plus 1 now. So we have rationalized the numerator. The radical is in the denominator, not the numerator anymore. So let's try direct substitution now. Let's take the 0, plug it directly in for x. Let's see if this will work. So it'll be 1 over the square root of 0 plus 1. Now the square root of 1 is 1, so this should evaluate to 1/2. So as we get this particular problem finished, this is it. So the limit as x approaches 0 of this expression is 1/2. So remember now, you're always going to start off by multiplying the binomial there with the radical. You're going to multiply by its conjugate. So you got the square root of x plus 1 minus 1, so you're going to multiply by the square root of x plus 1 plus 1. So you're going to multiply that to the numerator. You also have to multiply that binomial to the denominator also. And multiplying these two conjugates will give you a difference of two squares. And then from there, the x's will cancel out, and you can use direct substitution from there. So let me run through another example and show you another one and see how we do problem number 2. Okay, let's try this problem here. This time again, we're taking the limit as x approaches 0 of the square root of x plus 2 minus the square root of 2. All this over x. Now, once again, trying direct substitution. This gives the square root of 0 plus 2 minus the square root of 2 over 0. We have the square root of 2 minus the square root of 2 over 0, which is 0 over 0. There's the whole. All right, so let's, direct substitution didn't work, so let's take a look at removing the whole. So we're going to factor and cancel. In this case, we're going to use our rationalizing technique. Now, looking at the numerator here, the square root of x plus 2 minus the square root of 2. We've got two radicals. They're parts of a binomial. All right, so we're going to start off by multiplying. I'm going to put parentheses around this so it looks like a binomial. And we're going to multiply the conjugate of this binomial to the numerator and the denominator. Now, the conjugate, this is a minus square root of 2, so this will be the square root of x plus 2 plus the square root of 2. So we're going to multiply that to the top of the fraction. Then we're going to multiply the square root of x plus 2 plus the square root of 2 to the denominator. So we're going to multiply that to the top of the fraction and the bottom of the fraction. Now, as you multiply the two conjugates together in the numerator, remember that will always give you a difference of 2 squares. It'll be a subtraction. So this will be the square root of x plus 2 squared minus the square root of 2 squared. All this divided by x times the square root of x plus 2 plus the square root of 2. All right. And simplifying it further, removing both of these radicals when you square them. Now that's going to remove any radicals. This will give us x plus 2 minus 2 in the numerator. Okay. In the denominator, we still have the x times the square root of x plus 2 plus the square root of 2 now. All right. Now notice what happens. The 2's are going to add up to 0. Now you've got x over x. X in your numerator, x on the outside of your parentheses in the denominator. The x over x is the whole. So let's go ahead and cancel the x's out, just like we did in the last problem. Okay, these are both going to reduce to 1. Now remember, now you got 1 in your numerator divided by the square root of x plus 2 plus the square root of 2. So this will simplify then as 1 over the square root of x plus 2 plus the square root of 2. All right. Now, once we cancel the x's out, that's our whole. Now the whole's gone, so we should be able to use direct substitution on the remaining expression. So let's take the 0, substitute it in for x. This will give us 1 over the square root of 0 plus 2 plus the square root of 2. Simplifying this will give us 1 over. This will give us the square root of 2 plus the square root of 2 will give us 2 times the square root of 2. So evaluating our expressions should evaluate to this. Now if you simplify the 1 over 2 square root of 2, it'll simplify as, this will simplify as the square root of 2 over 4. All right, so if you write it, remember typically you wouldn't leave a radical in the bottom of a fraction, so simplifying it gives you the square root of 2 over 4. Okay, now the next example, let's take a look. We have one more example. Let's try example number 3 here. Right. Now, this third example, we have the limit as x approaches 3 of the square root of x plus 1 minus 2 over x minus 3. Now, what I want you to do with this problem, I want you to pause the video, and I want you to try this problem first. And then I'm going to work it out after you come back, and we'll kind of see if you were able to work it correctly. So, pause the video now. Okay, now I'm assuming that everybody has worked the video. You got your answer. Let's see if your answer matches my answer. All right. Now to start off, I said if you try direct substitution, all right, we'll substitute 3 in for x, giving us square root of 3 plus 1 minus 2. 3 minus 3 in the denominator. This would be square root of 4 is 2. 2 minus 2 gives you 0. 0 in the denominator. So if you try direct substitution, you end up with 0 over 0. That's the whole. All right, indicates that we've got a whole. Now, to start off, I said we're going to rationalize our numerator. So let's do just like we did the other 2 examples. I'm going to put parentheses around this here to make a binomial out of it. And I said we're going to begin by multiplying by the conjugate of that binomial. So this will be the square root of x plus 1 plus 2. We'll multiply that to the numerator. Let's multiply the square root of x plus 1 plus 2 to the denominator. So we'll multiply that to the numerator and the denominator. All right. Now, in the numerator, when you multiply the two conjugates together now, That's going to give us a difference of two squares. So let's see what we get. Now this would be the square root of x plus 1 squared minus 2 squared. All that divided by x minus 3 times the square root of x plus, plus 1. So plus 1 plus 2. Okay. So multiply the two conjugates, it will give you the difference of the difference of squares of the two terms. Right now, squaring both terms in the numerator here, this is we'll remove the radical from the first expression. Okay, that gives us x plus 1 minus 4, all that over x minus 3 times the square root of x plus 1 plus 2. Now, 1 minus 4 gives us negative 3, so it'll be x minus 3 in the denominator. So simplifying the numerator here. Now notice you got x minus 3 on the outside of your parentheses. That's going to cancel out. And we'll reduce to 1 with the x minus 3 in the denominator. So those are going to cancel. That was my whole. So we end up now with 1 over the square root of x plus 1 plus 2. Now once you get rid of your whole, all right, like we just did, the remaining expression we should be able to use direct substitution with now. So let's take the 3, plug it in for x, and let's see what we get. Now this will be 1 over the square root of 3 plus 1 plus 2. Now this would be the square root of 4, which would be 2 plus 2, or 1/4. All right, so evaluating this limit should give us a positive 1/4. So hopefully you were able to get that answer when you did the guided practice, when you just did it. So I'm going to do 3 examples. Like I said, this is a kind of a special case when you're evaluating limits. Typically you would factor and cancel, but with the radical here, the binomial radical, you have to use a conjugate to get rid of that radical in the numerator, and then from there you can go ahead and work it on out. So kind of a special case. When we get into our homework later, you'll see a couple of these problems like this, so I want you to know how to do it. Okay.